Okay, so this is my my second, well, really my third time doing this question, and there's been a technical problem the two previous times I did it, so I'm getting a bit annoyed at this stage, so I'm going to fly through it. Okay, this is on simultaneous equations. Right, and when we come to a simultaneous equation question, there are two questions there is a question that we need to ask ourselves. Okay, so we've arrived at some simultaneous equation question, and it could be something like this: 5a plus 2b is equal to 1, and 3a plus 3b is equal to 6. So it could be that type of simultaneous equation question, or it could be something like, let's say x squared plus y squared is equal to 53, and let's say 3x plus 6y is equal to, what's 3x plus 6y going to equal? 3x plus 6y is going to equal minus 30. So let's say that's the, I hope that's correct. Now I'm after making that up off the top of my head, but yeah, that should be okay. So that's our, so there are two different types of simultaneous equation question that you can possibly be asked. One, we spot doesn't have any squares, okay? There's not a square there, there's no square there, there's no square there, there's no square there. The other one, however, does have some squares in it, and that's the big difference. When there are squares, we have a different strategy, okay? The first strategy we're going to take a look at is when there's no squares. So we're going to be dealing with this thing over here, okay? So we're going to be answering that question. So I need you to park that for a second. So we're going to park what happens when there are squares. We're going to leave that alone. And we're going to deal with this question here. Let's go into blue maybe. That purple is looking a bit mad. So that's the job anyway. We're going to try and solve some simultaneous equations when there are no squares. Right. When there are no squares, strategy is kill off. That's the strategy. And the easiest letter for me to kill off is the B. So in order for me to kill off the B's here, it's a bit like spraying pesticide. So I'm going to kill off the B's by getting them to match up. So I'm going to get them to match up at the number 6. So I know that both the 2 and the 3, they both divide into 6. So I will have 6b and I will have 6b. Equals. And I'm going to call this one up here the top line, this one down here the bottom line. What did I do to the top line to turn its b's into 6b? Well, I must have multiplied the entire top line by 3. So down here I actually have 3 times the top line, which means that's going to be a 15a plus a 6b is equal to 3. The entire top line gets multiplied by 3. What did I multiply the bottom line by to turn what was 3b into 6b? Well, I must have multiplied it by 2. So I have 2b. And that's going to be now 6a plus 6b is equal to 12. That seems okay. Next job, I spot that if I add this line onto this line, neither the a's nor the b's will get cancelled or will get killed off. However, I do know that if I take the bottom line away, so if I take the bottom line away from the top line, so I'm now dealing with the ones in circles. If I take the bottom line away from the top line, the b's will kill each other off. Yeah, because I have plus 6b here, and I have minus 6b here. So if I now take the top line away from the bottom line, it'll work out for me. So I have 15a, take away 6a, that's going to give me 9a. The b's have killed each other off, and I now have 3 take away 12, which is equal to minus 9. If 9a equals 9, to get a by itself, well, we just divide minus 9 by 9, so a must equal to minus 1. Okay, that's pretty nice. Next job, I need to work out what my b is. So just like I have an answer for a over here, I need to get an answer for b. And normally when I say this in class, students say, well, we'll try and kill off the a's. So we go back to the very start and we try and kill off the a's. But it's a little bit handier than that because we now have this fact. Okay, we now know that a is equal to minus 1. So this thing down here is the truth. This is the truth. It is a true fact of truthfulness, okay? That this thing here, a is equal to -1, is the truth. Okay, so we now know Matthew, Mark, Luke, John, and this. Okay, this is the truth, that a is equal to -1. So if a is equal to -1, what is this a up here equal to? What's this a up here equal to? Well, a equals -1. That's the truth. That's what a is equal to -1. There's nothing else to really talk about there. So we must have 5 times -1 plus 2b is equal to 1. So I have turned this a here into a -1. Because that's our fact. A is equal to -1. I'm allowed to do that. So I now have -5 plus 2b is equal to 1. I'm sorry if my voice is sounding a bit irate. Like I said, this is my 3rd time doing this question. There's always been some sort of a technical issue. But let's keep going anyway. -5 plus 2b is equal to 1. So 2b must equal to 1 plus 5. So 2b must equal to 6. So b by itself must equal to 6 over 2. So b must equal to 3. So this thing down here, there's just flying through the algebra there, okay? You should be okay with that at this stage. If not, just take your time with it, pause the video, go through each step. So for example, to get rid of taking away 5 here, I added 5 over here. Let's get rid of him. Yeah. And to get rid of multiplying by 2 here, I divided by 2 there. So it's just straightforward algebra. So I now have my A and I have my B, so that's my question answered. So when there are no squares, up here, in the question there were no squares, when that was the case, it was just a straightforward, we need to kill off one of the variables. So the obvious question is, what do we do when there is squares? So let's take a look at one of those now. Oh, I think my pen is out of dying on me. Yeah, so I will try and entertain you guys while my pen charges. What'll I do? Quote some Shakespeare. When I do count the clock that tells the time, and see brave day, sunken hideous night, when lofty trees I see, barren of their leaves, which are from heated canopy the head, and summer's green all girded up in sheaths, borne on the bier with white and bristly beard. Then of thy beauty do I question, make that thou amongst the waste of time must go, since sweets and beauties done so sick, and die as fast as they see others grow. There we go, back, hopefully. Yes, thank God. That was getting a little bit embarrassing. Never mind. Okay, so let's try and copy this guy. Copy. Let's paste him down here. Paste. There we go. Right, and try and get rid of this guy here. Yep. So that was easier to do than I expected. So we're back into a simultaneous equation question, and we now have some x's and some y's. So it's a simultaneous equation, but we have we have some squares. So we need a new strategy. When we have squares, we need a new strategy. And the strategy we use in our class is isolate and substitute. So we are going to isolate one of the letters. So that's our first job, is to isolate. So we take a look at this line here, and we write it down, maybe 3x plus 6y is equal to minus 30. So we now have 3x by itself will equal to minus 30 minus 6y. So we now have x is equal to minus 30 minus 6y all over 3. To get rid of multiplying by 3, I divide by 3. So we now have x by itself is equal to minus 10 minus 2y. Can you see what I did there? Yeah, that this 3 here, he divides into both of these things. So this 3 divides into the minus 30, and he also divides into the minus 6y. So that gives us what? That gives us something quite nice. We now have x isolated. X is now isolated. So x is now isolated. All right. That's pretty good. X is now isolated. Yep. So what does that mean? That means that in our original question, I might try and put it back here. If I grab it here, I'm going to delete these guys here. Let's grab them again. Copy. Let's go down here. Paste. So we now have that x is equal to minus 10 minus 2y. So that means that that x there, he's also equal to minus 10 minus 2y. So I can rewrite the first line as minus 10 minus 2y squared plus y squared equals 53. Not too bad. Not too bad at all. What do we do? Where do we go next? How do I square two things? Well, what does it mean to square something? It means multiply it by itself. So I have to multiply this bracket here, I have to multiply it by itself. So I have minus 10 minus 2y times minus 10 minus 2y plus y squared equals 53. And then I can multiply out my brackets because I know what I'm doing here. I'm a student. I'm a competent math student. I know how to do this. So I have minus 10 times minus 10 is 100. Minus 10 by minus 2y is plus 20y. Minus 2y by minus 10 is plus 20y. And minus 2y by minus 2y is plus 4y squared plus y squared equals 53. And then I can make this a bit neater. I can say 100 plus 40y plus 5y squared equals 53. Yeah. And then, well, what type of equation do I now have? What type of equation is that when there's something squared? It's a... Yes, so that's a quadratic equation. So I have to solve a quadratic equation. Our system for solving quadratic equations is page 20. Minus b, blah, 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 blah. So I have to do that. I have to get this thing here into page 20 format. So I go to page 20 of my maths tables and I see it looks like this. ax squared plus bx plus c equals 0. So there's a number of things wrong with my line up here. Because first of all, my line is not equal to 0. And second of all, the x squared, this thing here, he should be out front. So I'm going to have to write this line. I have to write this line here with y squared out front. So let's do that. Let's go for 5y squared plus 40y plus 100 minus 53 equals 0. So 5y squared plus 40y plus 47 equals 0. Okay, so I now have it in the format ax squared plus bx plus c. So I now know what my a, my b, my c is. So I can now put it into the formula. So I have x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So it's 40, 40, b, b, a, c, which is 47, all over a, which is 5. And I can put that into my calculator. So I can go fraction minus bracket 40 plus the square root of 40 squared minus 4 times 5 times 47 all over 2 times 5, which is equal to, x is equal to minus 1.43 1, let's say, or x is equal to, that's what I get for making my own questions. I don't get nice answers. Hopefully I'll get a nice answer this time. Go back into it, change the plus into a minus. SD x equals minus 6.57. Okay, so that's not really what I wanted, where I wanted to be, but anyway, that's where we are. So I now know my x value and my y value. Sorry, I now know my x value and a second x value. So for each of these x values, for this x value and for this x value, there's going to be a corresponding y value. So I go back up to my original equation, and there should be a formula somewhere up here. Oh God. Sorry, lads. This is not my night. Sorry. Okay. A small little error. Okay, tiny little error that might be very confusing to you. And I know when I have to go back over something, it's even more confusing. Okay, so just try and relax. Okay, it's a tiny little error. Okay, and I just want to make it very, very clear now that I should have used, instead of x in this position here, that should have been a y. Because this equation here was in terms of y. So I have in fact not got values for x, I actually have values for y. I'm really sorry about that. I know it's really confusing. This is my third time doing this video and I'm not going to restart it now at this stage, okay? So yeah, just please appreciate that, okay? That this thing here is the answer for y. Okay? I know it's horrible when that happens, and when I was learning maths and the teacher made a mistake, it really annoyed me. I'm just trying relax, okay? Think about this, okay? That you should have been with me to where this equation here came from, and this equation was in terms of y. And if we use the minus b formula on this, our answer will be for y is equal to. So we now have y is equal to this thing here. Right? So that's our new fact that y is equal to. Now if we scroll back up here, we'll be able to see that formula that we have for x. See it here? And that will always happen when we do the isolate and substitute step. Because when we isolate, we get a formula for x. And that's what we're looking for. So I'm going to copy him just so I can see him down below. Copy. So I'm going to put him in there. Right. Maybe tidy him up a bit. So I now know that x is equal to minus 10 minus 2y. But I also know that y is now equal to this thing here and this thing here. So maybe when y equals minus 1.431, x will equal to minus 10 minus 2 times minus 1.431. X is equal to, I can put that thing there into my calculator, right? There's no x's or y's in it. Straight into a calculator. Minus 10 minus 2 times minus 1.431, which is equal to minus 7.138. Y is equal to minus 6.57. X is equal to minus 10 minus 2 times minus 6.57. X is equal to, and again I can put that into my calculator, minus 10 minus 2 bracket minus 6.57, and that's equal to 3.14. Look at that, it's equal to pi. So that's that is yep, that is the that's the answer. So we have worked out our y's here, We've worked out our x's here. Okay, so hopefully when you saw the isolate and substitute, you would have kind of, the system would have kicked in. The system you kind of should know in your subconscious. It should be in there somewhere. Okay, so that's how we solve simultaneous equations. Let's go back to the very top. Where is it? Where did we start? Here we go. So when we have simultaneous equations, we have two different types of simultaneous equation. It can be ones with squares or ones with no squares. When it's no squares, we kill off. When it's squares, we have to isolate and substitute. So that's how to solve simultaneous equations. Yeah, that's it. Okay. So I'm going to bed now. Good night.